In this video, I'll be showing how you can abstract the implementation details in a Golang software. So in this example, I'll be taking this application called Node Ledger, in which it is a simple note taking application. Here I will be showing you how you can abstract implementation details. For example, in this server, let's say there is a route which does add note. So what this function essentially does is that so you can see this endpoint, the highlighted one. So what it says is that whenever this slash note pattern is matched, we need to fire this add node method. And where is this add node method? This is in the right hand side. So this one will be fired whenever this request comes to this endpoint. Now the goal is that I will be adding this node to a database. But here is what I want to explain, that according to clean architecture, the innermost part of this, you can think of this architecture as in the shape of an onion which has multiple layers. So at the core of it is the business logic. On the top of that there is application logic, and then there is this frameworks and interfaces and implementations. So basically the idea is that the innermost layer of this onion should not depend on the outermost layer. Like for example, the domain should not depend on implementation details. Like in this add node, adding a node is my business requirement. This is my business logic, that whenever there is a note sent to slash note endpoint, I need to store it. But the implementation is that I will be storing it in MySQL database, in PostgreSQL database, in Redis, or wherever I want. So this is implementation. So the point is that business logic should not depend on implementation, because our implementation can change over time. Also the business logic can change, but it should not depend on implementation. Like in this example, I am storing it in MySQL database, but this might not be the case always. Maybe later on I want to store it in a NoSQL database like Cassandra or Scylla, or maybe Mongo. So this should not depend. So how am I going to do that in Golang? Here I can do it directly in this endpoint. In this endpoint add note method, I can directly store the data to the MySQL database using SQL queries. But I won't be doing it this way, because we want to abstract the implementation detail. Implementation detail is here. So let's go to this pkg. There is this db method, you can see. So here if I open this up, so in Go the idea is that the interface has methods. Now whichever type implements those, all of the methods of the interface, both of them become of the same type. So here we will write this method for, so as you can see in connection, we have created a connection. I haven't tested the database yet, but it should work. Typically it should work. So here I'm implementing the add note method here. The add note method, which will be called from here, is actually implemented here. So let's see how it is done. So first of all, what we will do is that create a database structure, then implement this add note method here. So I'll be doing it this way. DB has MySQL connection. To this I will do a query. I can do an execute as well, because this is an insert. This results and result and error. So need to handle two things. I don't need the result. I can, in Go you can ignore it this way. Here I will be writing my SQL method. It should be, so let's check what is the type of the database, the schema. schema can be found in MySQL. So it is, I think the database is note ledger. Now let's see what tables are here. Let me describe this notes table. It is of this type. So these fields I need to populate. Now how I'll do that is I will write insert into, the table name is notes, insert into notes. The fields are note ID, user ID, note ID, user ID, then note type, note content, note type, note content, and then there is a bucket. Or I can maybe write it this way, it looks better. This is just for sake of making it look a bit different. And to it the values would be 1 2 3 4 5. 1 2 3 4 5. This takes care of that there's no SQL injection possible. Okay, so I think we are good to go, and here we will pass the node data and bucket. So add node will need actually not just these three, note ID and user ID as well. So there is this note ID of type string, then there is user ID of type string, then there is this note type, then there is the note content, then there is this bucket. These values I'll be populating. First is note ID. Okay, note ID, then user ID, then note type, note content, and there is bucket. This way we made this, and we need to handle it as well. So error is not equal to 0, we'll return error, otherwise we'll return nil. Or we can do it this way as well, since there is only return statement, so we don't need to capture it this way, because at the end note will be nil if there is no error. So we actually don't need to do this. We can simply do return error. That should take care of it. Now in add node we need to, we have, so now you'll see that the server instance also has server has an instance of database. There is a database, there is a router. So we'll use that for making the request. So if unmarshal it to tn variable at line 7 from the current line top. Now what we'll do is that we'll do if error equal to s dot database. Since this has implemented add node, we'll just use this add node, then we'll pass the values here. Tn first is node id. So node id is something which will be populated automatically because that is of type auto increment. So you can see the type here. Node id is auto increment. User id is something we need to create. We'll be using an UUID for that. Ideally this user id is something which we'll get from uh, sign in sign up page, authentication page, but for the sake of simplicity we are passing a hard coded value here. Actually we don't need node id because it is of type auto increment. This will be incremented automatically. There is no node id. So user ID is something we are just creating randomly, because actually this is not, as I was telling, this should not come from here, it should come from the authentication part, but for the sake of simplicity we are using it here. So to add node we are passing first of all this user ID, then we need to pass the node type tn dot node type. In this case also we need to hardcode because this in this case will be text, because we are hoping to add the type of image and videos as well later on. So here it will be text, we can do it anything. Tn so this is node type, so this is node type, then we need to pass the node content, the actual content, tn dot node, then we need to pass bucket, tn dot bucket. And I think we missed one part, that here we could have added the a new field like date. That would have been good, but we'll do it later on. This is how you execute it. Not equal to nil, we need to return an error. Ideally we should do it in a better way in JSON format, but here doing it this way. Error code, let's say, is 500, and we'll paste it here, then we'll return. It takes an error string, then error code. Okay, then error code is, let's say, 500 internal server error. We did error.error so that it passes a string. Okay, I think we are good to go. All right, let's test it out. So we should go to server, then run it. It says it does not have fielder method add node. Okay, let's see what happened here. Main.go 29. Where is main.go? This is main.go. Where is 29? It says server.add node. It says that it does not have it. Okay, so what is the problem? Let's see. I can say it is here. Why Why is it showing this? So it is in routes, main.go, routes. Let's run it in a different terminal. Okay, we are already here. Server has no method add node, but this should not be the case because we know server method is here, add node. So what is this happening? It is able to open it as well. Then what is the problem? Because I was able to go to definition from here. Okay, so let's try compiling it. Okay, we'll do go install, then run the server. It says this directory is not there, conf.json. Interesting. No such file or directory. Could not read configuration. Okay, so what's wrong here? So where is it used? Should have been used in connection part, right? So here you see we are doing this open get config. We can pause this configuration here as well. Let me move it there. Node ledger pkg, then it is what config. I just pushed it to a config package. Let's see, where is the conf.json file? Okay, so it has gone there. Okay, so I'll move it to pkg config directory. Now I think it should be better because now it is in local. So now when we'll do set env, the path that we will provide to it Or what we can do is that we can provide the absolute path to this one. Absolute path always works. Let's move it. Let's move it to root. Let's see, where is it? Okay, it is still there. Let's move count.json to 2 steps backward, which is the root. Okay, so we'll pass the complete path to the file, configuration file. Okay, where was it? So we would be passing it here. I think we just copied it, or didn't we? This is the complete path. Okay, now I think it should work. Let's see. Server has no field or method add node. This is weird. But if I do install it and then run the server, so on which port is MySQL running? I think I did forget the port. The port of MySQL is so what port did we provide here in the connection? It seems we have provided the port, but anyway, let me just check once how to provide the port. This database connection was not checked by me. Three 3306 is typically the port. Okay, so what do they look like? Let me check. It's just for logging purpose. What do config.db username and password look like? Or maybe this. Just let me check what is the username in case we are able to, just checking that we are able to parse it properly. username colon password @tcp 127.0.0.13306 slash table name. I think it should work, but let's test it out. Okay, I think we should import MySQL table as well for side effect. So this is importing a package for side effect. You do it this way: github.com go SQL MySQL. I think this should be fine. Let's try it out. This is interesting. Does it mean that it is not installed? So let me try importing it. I'm pretty sure this should be already there, but let's check. It is there. So what is the problem? Can't find it here. I'm not sure why this is happening, but let's comment it out, and I'll use go vims this method, go import github.com slash go SQL. Oh, was there a spelling mistake? Oh my god, this is bad. So I was doing a spelling mistake, not spelling mistake, I missed this part. Go SQL driver, this is the driver, that's why we are importing it for side effect. Side effect in the sense that we need the init method of this package. Seems fine. Okay, seems to be working. Now we'll use Postman to make a request. Right now, as you can see, there is nothing in notes. I haven't done any insertion. Yeah, it's empty set. But now we'll make a request. This is running in localhost 8192 slash node. Localhost 8192 slash node. Okay, let's see. Incorrect for user ID. Okay, user ID should be an integer. Still, if you see that there is nothing in table yet. So what the mistake we did is that in the implementation of node, the user ID we passed is not right. User ID needs to be of type integer, but we are doing a string because you can see the schema here. Node ID is of type integer. User ID of type integer, but we are passing string here, which is wrong, which will be eventually fixed because right now we are just passing it any value. This would be UUID typically. Let's say we make it user ID 1. Now let's check. Closing it. So as you can see, we were able to pass the note at least from Postman to our server, but this was not inserted to database. User ID is of type integer here. Okay, installed, now running the server. Cannot add or update a child row, foreign key constant not legit. Okay, so this user ID, there is a foreign key reference, so there needs to be a user ID of type user ID 1, because this was, so if you see the users table here, there is no value in users, but there needs to be one, because the user ID of nodes is foreign key to user ID. Since there is no user ID in users, you cannot pass one in nodes. So let's quickly create, insert a value here, insert into users. There is this user ID field, then name, then password. I'm just creating a dummy user, email, and there is the values. The user ID, let's say, is 1. There's any auto increment, so let's not pass any value there. Pass the name as test, then password should be super hard, like 1 2 3 4 5 6 7 8. Oh, this is character, so let's do it this way. Super hard, super useful. And email is something like abc@bcd.com. There is no check on that yet. This should be good to go, except the fact that we are passing user ID column as well. This should by default be 1, because we are auto incrementing just. Let's see. Okay, there is an error. Okay, this needs to be a string. The email. Let's make it a string. Okay, let's see. Okay, so we were successful. So let's start from users. You can see there is user ID 1. Now I think we should be able to do it. Note added successfully. You can see server quotations, server logs here as well. First of all, it was this, then again this time we failed, then again add node. This is added. Let's see if there is anything in notes table. So you see, we were, a note ID was okay. So we were passing user ID 1, which is fine because now we have a user with user ID 1 as well. And we passed note type text, and the note was, this is my first note, and bucket is life, which is kind of like a playlist. So you can see that we were able to store values to database, and we abstracted the implementation detail, because let me just go through it simple once. Let me start with the routes, or maybe main. So you can see whenever there is a request to /nodes endpoint, this add node function will be called. This add node function, what it does, okay, this is, what it does is that it further calls this method for adding it to database. But this method, we didn't actually do it here. We created a database instance, and the database instance further does it. Ideally, we would see later on how it is done is that we will create an interface and implement those methods, and then we'll pass the implementation detail there. So I guess this was clear. This will be more clear if I add more example where we'll be dealing with domain specific logics and then doing it the interface way. Here we didn't do it the interface way because it was not required. We were directly making the calls from the server itself. Server has the instance of database, so we were just doing it this way. But ideally what we'll be doing is that we'll create a repository interface, or let me just do it here only. I guess I can do it here. So what I'll do is that in Node we'll create a repository method repo.go. In that we'll create an interface type repository. This is typical naming convention, we can name it anything. Interface, what it will do is that it will add node. I guess this is not required here. Oh no, we can do that. We can do that. That's fine. Add node. What add node would do is that we are defining the structure here. The prototype. It will take a user ID of type integer, node type of string, node content of type string, then bucket of type string which will return an error. This is all that interface is about. Now in this we can actually define the business logic. But business logic here is very simple. There is no processing involved here. It's like add user node which will take type repository, and then the other fields like user ID, type integer, node type string, use node content string, bucket is also string. Let this return error as well. So now, as you've seen, this is the business domain. We are in the node package, as you can see here. We are in node package. We don't know how this add node method will work, but what we'll do is that, let's say we run log.println, let's say adding node from domain. Now we don't know how this add will work, where this add is going, how this add will work, but what we know is that there is an add method. We need this interface, we need this method for adding it. So let's do it this way. I captured the error here. I know this repo interface has this method called add node and pass the values here, user ID, node type, node content, and then bucket. Then we'll just return error. So as you see, we don't know how this add node is going to work. We just know that we need this. Now in the server, let's not do it this way. Rather, let the server have an instance of where we are creating this server. Let's say this server has an interface connection to nodes SVC, which is of type node dot it is package node dot repository. Let's see if it was able to get it by itself, but no. What is the package name? Package name is node. Let's import it here. Go import github.com/color node ledger, then there is node. pkg, then there is node, and let's do it this way. This node package has this interface repository, and here you'll see that we will pass the logic here. Let's make it capital. Here you see that we just defined an interface. We don't know how it is implemented, but we know that we need this, and here we will pass the instance of the implementation. Now here we know the implementation is in database, so we'll just do it here. Say the database is here, and we'll pass that instance to wherever it is required. So pass the db here, pass the db method here as well. And 20. Okay, I'm seeing an error here, but I'm not sure why this should be happening, but let's see. Now here we won't be calling the data. This is the add node. If you see the very right split, you can see that we were earlier calling the database directly, but we can go a step further and just do it from the domain perspective. So if there is a node logic, so we'll go to s dot node service. This node service has this add node method. And since we know the node service was provided the instance of database, this is how we abstracted. So let's see. Repo.go. Okay. Oh, okay. We forgot to provide package name here. That's why I guess it was not able to find the package. So it is package note. Now I think this should be fine. Let's see. Okay. Now let's run. As you can see, in nodes there is just one field, in users also there is one field. Let's see if it works. Node added successfully. In the logs you can see this running was there. In nodes there are two fields, node 2, node 3, same content. Okay, this seems to be working fine, but the main point of this video was that abstraction of implementation. So here you see in the very right, okay, let me close the other fields. So at the very right, you can see that this is the method which works, which runs when there is a request on slash note at endpoint. Here the point was that we are doing it to note SVC, which is here in the left split. What it does is that it does not know how this addition will work. It just knows that I need to add. And this is being called from the server as well. But where was this implemented? This was implemented in database. How? It was implemented this way. I just kept the prototype similar, signature of method similar, and this is implemented by db struct. So during creation of this server, I just passed the database instance to node SVC method. And this is how we abstracted the implementation details. Now this node package is unaware of how this implementation is going on, and later if you want to do it some other way, we can just pass a different instance in this highlighted field, instance of the structure which does the implementation, and we should be good to go. If there are doubts, you can ask in comments. Thank you.